Stephen Hawking, Brief Answers to the Big Questions. Embark on a journey through space and time as we explore some of the universe's most beguiling enigmas, brought to light by the late Stephen Hawking's insightful book, Brief Answers to the Big Questions. This summary will guide you through topics spanning the possibility of a sentient God, the origin of the universe, life on other planets, and even the potential of time travel. As you traverse Hawking's universe, we'll delve into the implications of advanced artificial intelligence and the rapidly evolving world of scientific discovery. Brace yourself for this enlightening cosmic adventure that's bound to challenge your perspective on the universe we inhabit.
Unraveling God and Natural Laws. We've long sought answers to life's biggest questions, initially through religion and later through science. Both share the human quest for meaning but result in contrasting conclusions. Natural laws, though universal and unchanging, are often pitted against the concept of God. However, by redefining God as the fundamental laws of nature, a powerful connection can be established between scientific principles and the essence of spirituality. Throughout history, we've been driven to understand and explain our universe, searching for answers and deeper meaning. Early explanations were rooted in religion, as gods were seen as the driving forces behind natural events like lightning, storms, and eclipses. Today, however, we primarily rely on a more rational, consistent, and verifiable explanation. Our universe functions as a vast, complex machine, guided by natural laws that remain unbreakable. To illustrate this concept, consider a tennis game. The trajectory of the ball is determined by natural laws such as gravity and motion. Although variables exist, like wind speed or player strength, they merely serve as data points for these laws, collectively determining the outcome. These laws are both unchanging and universal, dictating everything from the simple bounce of a tennis ball to the revolution of planets and the course of a meteor through outer space. The idea of a divine creator might seem negligible when pitted against the natural laws governing the cosmos. However, reconciling modern science with the idea of God is still possible. This reconciliation involves redefining God as the fundamental laws of nature, rather than envisioning a conscious, human-like creator as often depicted in religious contexts. While this perspective may be unsatisfying to those who seek a personal relationship with a sentient deity, it bridges the gap between faith and reason. By acknowledging the universal and unbreakable characteristics of natural laws, viewing them as a divine force allows for a more powerful and meaningful connection between the scientific principles we observe and the spiritual essence often sought in religious understanding. Rethinking the Big Bang. The Big Bang is a widely accepted theory explaining our universe's origins, which can be traced back to an infinitely dense point. In 1929, Edwin Hubble discovered that galaxies are moving apart, the more distant, the faster, suggesting that everything was once concentrated in the same spot. Further evidence for this theory arose in 1965 with the discovery of faint background microwave radiation, likely a remnant of the initial explosion. Understanding what came before the Big Bang involves the concept of spacetime, which can be warped by massive objects like black holes. As the universe contracts to an infinitely dense singularity, time and space cease to function in accordance with our classical understanding, leading to the conclusion that the Big Bang had no cause because time did not yet exist. The odds of intelligent life. The intriguing concept of alien existence has sparked curiosity for ages, and there's some evidence to support the probability of their existence. Earth's age and habitability for billions of years provide reason to believe that extraterrestrial lifeforms have indeed evolved. Furthermore, Earth-like planets within habitable zones are abundant, with about 40 billion potentially scattered throughout the Milky Way. However, the rarity of intelligent life, such as the complex leap from single to multicelled organisms, may explain why we have yet to encounter alien civilizations. Aliens have long captured our fascination, featuring in movies, novels, and even personal accounts of supposed encounters. Given our only example of habitable conditions, Earth, it appears likely that life beyond our planet does exist. The Earth itself formed when the universe was already 7 billion years old. During that time, many alien civilizations may have had the chance to evolve, master space travel, and colonize their galaxies. The immense timeframe for life to develop isn't the only factor warranting consideration. Earth-like planets must also exist within habitable ranges for life to thrive. Approximately 20% of all stars are orbited by Earth-like planets located within their Goldilocks zone, habitable areas neither too close nor too far from their stars. Considering the Milky Way is home to roughly 200 billion stars, there could be up to 40 billion Earth-like planets in our galaxy alone. If the likelihood of extraterrestrial life is so high, why haven't we made contact yet? One possibility is that while life may be plentiful, intelligent life forms are exceedingly rare. For example, it took Earth 2.5 billion years for life to advance from single-celled to multi-celled organisms, a key step necessary for intelligent life to develop. The progression of life on other planets might be stunted by their stars going supernova or being wiped out by cosmic events. Earth itself has faced significant challenges, including the asteroid or comet impact 66 million years ago that eradicated the dinosaurs, once the planet's dominant species. Given the likelihood of such catastrophic events occurring every 20 million years, the evolution of human life on Earth might be attributed to sheer luck in avoiding an interstellar collision. So, while the existence of aliens may be probable, the luck and rarity of intelligent life might explain why we haven't yet made contact with extraterrestrial beings. Predicting the future, fact or fiction? Predicting the future has long been an intriguing prospect for humanity. French scientist Pierre-Simon Laplace postulated that knowing the positions and speeds of all particles in the universe could enable us to calculate their future behavior. This principle, while central to classical science, has its limitations. German physicist Werner Heisenberg introduced the uncertainty principle, hindering Laplace's thought process by establishing that simultaneously measuring a particle's position and speed is impossible. Quantum mechanics then emerged as the alternative theory to explain the universe, bringing its own set of complications and uncertainties. Many have dreamt of glimpsing into the future, foreseeing lottery numbers, anticipating exam questions, or avoiding life-threatening situations. But is such foresight truly attainable? While direct future prediction remains improbable, there is one scenario to consider. Laplace posited that understanding the exact positions and speeds of all universal particles could reveal their future movements. For instance, if you knew your car's location and speed at a specific moment, you could predict where it would be in 30 minutes. This concept is rooted in the principle that the universe's present state determines its future trajectories, theoretically enabling future predictions. However, Heisenberg's uncertainty principle contradicted Laplace's supposition. Due to the discrete packaging of light waves into quanta, it became apparent that measuring both the speed and position of a particle with absolute accuracy is impossible. This revelation signaled a need for a new perspective on understanding the physical world. Quantum mechanics, a complex theory that emerged in the 20th century, provides that alternative viewpoint. Instead of clearly defined positions and speeds, particles in quantum mechanics have values represented by wave functions. Each wave function consists of numerous points in space, with its size forecasting the probability of locating the particle at any given point. To estimate a particle's speed at any location, one can measure the variation between two spatial points within the wave function. Despite its potential, quantum mechanics presents numerous challenges. Firstly, it allows for only half the information available in classical science regarding particles, providing the wave function but not the exact position and speed. Moreover, quantum mechanics falters under extreme conditions such as warped spacetime, typically found within black holes. While predicting the future has always captivated our imagination, our understanding remains constrained by the limitations of scientific theories like the uncertainty principle and quantum mechanics. The enigma of future prediction persists, continuing to pique our curiosity and fuel our sense of wonder. Unraveling the black hole mystery. Imagine being on a thrilling space journey, only to find yourself in the clutches of a black hole, where gravity threatens to pull your ship towards a deadly fate. Thanks to collapsing stars and their massive gravitational pull, black holes come into existence. These astronomical phenomena are kept in check by a star's thermal pressure and nuclear fuel. However, once a star exhausts its nuclear fuel, it contracts and forms a black hole. Black holes are not completely inescapable, as Stephen Hawking discovered that particles are released from black holes through quantum mechanics processes. The interaction of these particles causes black holes to lose mass, ultimately disappearing. Embark on an exhilarating interstellar space adventure with a young, eager captain. Amid the excitement, your ship drifts off course and spirals into the grasp of a formidable black hole. As you're pulled closer to the point of no return, would you find solace knowing you'll see beyond a black hole's event horizon just before collapsing into stardust? Black holes arise from the collapse of stars, attributed to their enormous mass that generates immense gravitational forces. During a star's lifetime, its own gravity is countered by thermal pressure through nuclear processes, converting hydrogen into helium. This delicate balance prevents stars, like our Sun, from imploding prematurely. However, when a star's nuclear fuel eventually depletes, it collapses under its own gravity and forms an infinitely dense and small point called singularity, a black hole. The event horizon surrounding a black hole is like the edge of Niagara Falls. Once you cross it, there's no turning back. But as the universe has existed for billions of years, why isn't it teeming with black holes? It turns out, black holes aren't eternal traps. Stephen Hawking's groundbreaking 1974 discovery demonstrated that black holes release particles through quantum mechanics processes. Space is teeming with particles and antiparticles constantly bonding and annihilating each other. When these pairs interact with black holes and are separated by the event horizon, black holes gradually lose mass, shrink, and vanish. Now, breathe a sigh of relief and let's navigate the mysteries of our own species. Balancing Earth's dual dangers. Our beautiful blue planet is facing a myriad of potential disasters. Threats both external and internal are staring us in the face, and it's high time we take these perils head-on. Asteroids crashing into Earth may seem like a scene from a sci-fi movie, but the odds aren't in our favor. However, instead of stressing over those uncontrollable universal events, why not channel our collective energies towards the challenges we can control? Climate change is perhaps the most immediate and urgent threat to the planet. With rapidly rising temperatures and melting ice caps, Earth's environment is gasping for breath. The greenhouse effect poses a grim future if we don't employ innovative technologies and implement responsible policies to curb our carbon footprint. Otherwise, we risk transforming our world into a Venus-like inferno. But another lurking danger is nuclear annihilation. Cold War rhetoric might seem far off for many, but it remains an ever-present reality in the geopolitical landscape. Our best shot at survival is developing advanced technology to eventually evade catastrophes, be it environmental or nuclear. Together, we can address these challenges and preserve our home, Earth, for future generations. Rekindling our cosmic curiosity. At the time of Christopher Columbus, voyages to uncharted territories faced skepticism just as space exploration today. The spirit of curiosity, exploration, and deadlines are essential to reignite the public's interest in space. As our knowledge of the solar system expands, so too does the potential to explore neighboring celestial bodies. Current technological limitations are real, but projects like Starshot showcase our creativity and potential to unravel the mysteries beyond our solar system. Just as the exploration of uncharted lands once faced skepticism, today's space exploration endures similar resistance. From budget cuts to dismissive attitudes, people question the value of exploring the cosmos. Despite these modern hurdles, humanity has a unique instinct for curiosity, exploration, and the need to push boundaries. Envision being stranded on a deserted island, with no intention to leave. It's unfathomable to the human spirit. To reignite the flame of space exploration, we must set defined deadlines and goals, much like President Kennedy's 1962 commitment for a manned moon landing within the decade. These goals play a crucial role in capturing the public's imagination and fostering future generations of scientists. Based on our technological capabilities today, Moon base by 2050 and a manned Mars landing by 2070 are achievable targets that can renew enthusiasm for space. Our journey doesn't end there. It's within our reach to explore other planets in our solar system within a century. Even Europa, Jupiter's moon, has the potential for life-sustaining water beneath its icy surface. However, we face considerable challenges in venturing beyond our cosmic neighborhood, as the nearest solar system, Alpha Centauri, is 4.5 light-years away. Knowing that our current chemical rocket propulsion lacks adequate speed for interstellar travel, alternative energy sources like nuclear fusion or matter-antimatter annihilation need considerable development before becoming viable. In the meantime, unmanned spacecraft offer a feasible solution to explore distant star systems more swiftly. An exemplar of humanity's ingenuity is the Starshot project, involving the creation of 1,000 nanocraft space probes with lightweight sails. Sent into orbit and propelled by laser power, they promise to explore beyond our solar system. Despite its engineering challenges, Starshot reminds us that our species is capable of astonishing creativity and innovation. As we continue to push the boundaries of space exploration, let's reignite our cosmic curiosity, embrace the spirit of adventure, and boldly pursue the knowledge that lies in the uncharted territories of the cosmos. Exploring AI's double-edged sword. While artificial intelligence, AI, appears as an apocalyptic and far-fetched concept in movies, the reality of superintelligent machines could change our lives for better or worse. Currently, our brains are far superior to any computer system. However, with the rapid advancement of technology, an AI capable of self-improvement could surpass human intelligence, potentially posing a real threat to society. On the flip side, AI has the potential to improve life in numerous ways, including the eradication of poverty and disease. Despite these dual effects, prominent entrepreneurs and researchers are pondering the ethics and the need for safeguards to ensure AI serves humanity. The concept of an advanced artificial intelligence causing a catastrophic series of events like in the famous Hollywood sci-fi movies might seem far-fetched. However, by ignoring the potential reality of superintelligent machines, we risk committing a grave mistake. Our current level of intelligence far exceeds that of even the most sophisticated AI, making them seem like mere earthworms in comparison. Yet, this gap may not always remain. AI has the potential to revolutionize various aspects of human life, such as eradicating diseases or poverty, and contributing to countless improvements we cannot yet imagine. Though technological advancements seem cutting-edge now, the continuous growth in computing power propels them forward rapidly. Moore's law, for instance, states that a computer's speed and capacity double roughly every 18 months. Consequently, AI could potentially surpass human intelligence within a century, rendering scenarios like self-aware machines less implausible. Acknowledging these possibilities, prominent figures like Elon Musk and Stephen Hawking have cautioned against the potential risks of uncontrolled superintelligence. As AI ethics emerges as a rapidly growing academic field, realizing threats and opportunities of AI's trajectory is crucial. Looking ahead, ensuring that future machine development remains in service to humanity is of utmost importance, striking a balance between harnessing AI's promise and preventing a dangerous intelligence explosion.
After venturing through the vast cosmos in a brief answers to the big questions, we come away with a deeper understanding of the profound questions that have intrigued humankind since our existence. Hawking eloquently presents concepts like the Big Bang, the unbreakable laws of nature, our universe's expansion, and the complex world of quantum mechanics. Alongside these perplexing phenomena, he tackles the manifestations of artificial intelligence and its implications, the tangible threat of climate change, and the encouraging potential of space travel. Through this engaging exploration, we are left humbled and invigorated, inspired to continue our pursuit of knowledge and understanding of our place in the cosmos.